Hi everyone, this is Lab 10.1, Introduction to Titrations. So what we're going to be doing here is titrating a strong acid with a strong base. And specifically we're going to be using HCl, hydrochloric acid, of an unknown concentration, and titrating that with sodium hydroxide of known concentration. The concentration of this sodium hydroxide is 1 molar. Now, first we're going to titrate our acid to determine the concentration of our acid, and then after we know the concentration of our acid, we'll be able to work backwards and figure out the pH of our solution at multiple points along our titration curve. Now, before we actually get started on the lab here, I want you to pause the video for a brief second and jot down the acid-base neutralization reaction that would occur between HCl and NaOH. Great. Now, examine the salt that forms as a product of this reaction. Is this salt going to be acidic, basic, or neutral? Great. As we know, NaCl is the product of a strong acid and strong base reaction, and that salt will have negligible acidity or basicity. So with that being said, we have a neutral salt forming. Okay, now to get our lab set up. So what I'm going to do is I am going to fill our burette with sodium hydroxide. See here, we have our funnel, pour it in. We used burettes when we discussed redox titrations in Unit 5, but just a reminder, this device allows you to dispense very accurate amounts of a solution. So what we're going to be able to do, ladies and gentlemen, is have a specific amount of sodium hydroxide used. So it's important to jot down the initial volume of sodium hydroxide. Let's go ahead and do that now. So taking a look here, I'm seeing this right at about 0.90 milliliters to start. So let's jot down that value. Now, why is it important to know the amount of sodium hydroxide used? Well, look back to your balanced chemical equation. I know the concentration of the sodium hydroxide. If I know our concentration of sodium hydroxide and I know the volume used, we can multiply those values together to get moles of sodium hydroxide used. Now, looking at your balanced chemical equation, you're going to see that the amount of moles of sodium hydroxide reacted will be equal to the amount of moles of hydrochloric acid reacted, as those two substances react in a 1-to-1 mole ratio. So if I'm able to figure out how many moles of sodium hydroxide reacted, I will also know how many moles of hydrochloric acid reacted. Ultimately, our goal in the first part of this experiment is to determine the concentration of our unknown acid. So we have a method for how we are going to get the amount of moles of acid reacted. Now let's take into account the volume. So to get the volume of our acid, I'm simply going to measure out a specific volume of acid. Now, I'm going to try to get this around 25 milliliters, but if we are a little bit more or a little bit less, that is okay. We just have to write down the overall initial volume. So whatever that is, we just have to write down the actual value. So I'm going to get down to eye level here, try to get around 25 mLs. Okay. That is like exactly 25. 25.0 as our concentration for hydrochloric acid. Sorry, as our volume for hydrochloric acid. We don't know the concentration yet. So I'm going to transfer our hydrochloric acid to our Erlenmeyer flask. And to ensure that all of the acid transfers from the graduated cylinder to the flask, I'm going to rinse this with some deionized water and add that to our Erlenmeyer flask. Now you may be thinking, isn't that going to impact the concentration, Mr. Rice? It's a good question. We'll talk about that in the error analysis portion of the lab at the end of, or when we actually finish collecting all of our data. Just keep that in the back of your mind. Okay, so I have my setup almost ready to go here. Let me get a plastic pipette. Now, as you notice, both our hydrochloric acid and our sodium hydroxide solutions are both clear. So what I'm going to do is I'm going to add what's known as an indicator to our acidic solution. Now, the indicator that I'm using is known as phenolphthalein. Now, what does an indicator do? An indicator switches colors or has a solution switch colors when there is a change in pH. So for this particular titration and indicator, just added a couple drops into our acid, we will see a pink solution form when the pH gets, I believe, above around 8. So phenolphthalein changes about 8 to 10 pH. So when we get to the equivalence point, or just slightly beyond the equivalence point, we will see a change in color for our pH, or for our solution. So that's what we're looking for. Now, not only are we going to be collecting this initial data, but about every 10 milliliters or so, I'm going to use a pH test strip, and I'm going to test the pH of our solution. So that way we can kind of compare it when we start doing our pH calculations as part 2 of this post-lab. Okay, so I'm going to get my pH strips ready to go. They look fairly green to start. The reason why I say that is usually they look fairly yellow to start, but that's okay. So I'm just going to grab a bunch, leave them off to the side there. So we can use these as we go. So I'm going to add actually, let's get an initial pH. Before we add any base, let's take a look at what the pH is around. Okay. So, as to be expected, strong acid. It's fairly red. If you look at the end of the lab, you'll see I've included the picture that helps you match up with the pH chart. So I've included this at the end so you can compare the pictures of our pH test strips to the sliding scale of pHs. Okay, so we have our initial pH. Let's start dropping the base and get this experiment underway. So I'm going to add about 10 milliliters of NaOH to start here. Now, if you notice, probably too far away, let me bring you a little bit closer, that the second I start adding base, you will start to see a little pink forming right where the base hits the solution, because that at that instant, that portion of the solution is basic, and the indicator is telling you that. So see it, take a look here, see if you can see it. You can kind of see that pink forming. Okay, so we've added at this point about 9 milliliters of base. What I'm going to do, let me back you up here. What I'm going to do is simply test the pH again. So I've added, what are we at? We're at 9.20 milliliters. So I'll have this all on the document that you're writing down. I'm just going to jot it down. So 9.2 milliliters of NaOH has been added. Let's take a look at our pH using a test strip. Okay. Just bring this up again. Still fairly red. Okay. It's 9.2 milliliters of NaOH. Now, that's not 9.2 milliliters added. That is the volume right now. We'd have to subtract that value of the initial value of 0.9 milliliters where we started. All right. So let's keep adding some base here. Now the pink is staying for longer in my solution than it was initially. So that means we're getting closer to the equivalence point where we have had equal moles of acid and base that have reacted. Remember, we don't want to overshoot our titration. I don't want to go too quickly here. Okay. Our volume at this point, let's get another pH reading. So our volume at this point is about 21.80. So we'll get another pH reading here. Okay. Starting to see it's still red, but it's less red than our other examples. Okay. Now we are getting closer. We got to be careful at this point not to overshoot the endpoint. Living dangerously right now, ladies and gentlemen. I'm really living dangerously. All right, let's take another pH reading right now. So we are at 31.30. 31.30, so that was almost 10 milliliters. Okay. This one will be fairly noticeably different. Okay. So now I really got to be careful because we're getting close. You can see I'm letting out the sodium hydroxide dropwise. Just letting out a handful of drops at a time. And what you'll notice is that the pink indicator is really floating around in solution. This tells you, and when the pink kind of just stays in solution, now if I shake it up, mix this around, it will go away. But that's indicating to me or telling me, hey, you're getting relatively close to the equivalence point here, so be careful, slow down. So to avoid doing this twice, we are going to be extremely careful. Now our pink is remaining for a little bit. We're close. If you're still watching at normal speed, feel free to speed this up. Okay, we're getting very, very close. 2 drops at a time from here on out. Thought I got a little bit too careless there. One drop too far, ladies and gentlemen, but we're going to use this volume. One drop too far. So this is an embarrassingly too pink solution. So I don't know if you saw what I did there at the end. I tapped one extra drop into the solution, went from clear to this pink. So full disclosure, I overshot this titration. What you are looking for here is an extremely faint pink solution. We have a dark pink solution. Now, as I was being very careful, I do know that I overshot literally by 1 drop of sodium hydroxide. So we're going to use this data. Be aware, it is slightly too much. And we can talk about that in the error analysis section as well, in terms of how that will impact our results. Now, what we need to do here is take a final volume of sodium hydroxide. So I'm lifting this up so I can see our burette. We are at 36.80. 36.80. So we're going to jot that down as our final volume of sodium hydroxide. And now, let's take the pH using our pH test strips. And then let's add some more base. To then get a final pH of our solution. Okay. You can see a little bit different. And now let's add excess base and get one more pH reading. So I'm just going to add some excess base. The amount doesn't matter here because we're just using this to calculate pH later. Okay, so our next reading is 45.50. And let's take our final pH test. And what do we see? Boom. Blue again. Now that you've seen the experiment and hopefully you've jotted down all of the data, we will work through calculating the concentration of the acid together, and then also discuss how we would calculate the pH of this solution multiple places along the titration. So at all of our different pH ratings, we will actually be calculating the numerical value for the pH. Good luck.